Hello there.
Hello there.
Welcome back to Math with Patrick. Today is May the 4th. Happy Star Wars Day. And we're solving problem number 124 from this Daily Epsilon calendar. And I've been staring at this problem for like 20 minutes. I've been pacing around kind of like that for 20 minutes, just staring at this problem. Um, Let me kind of like run you through my thoughts. So we're trying to find this area of the blue triangle down here. And so initially I was thinking, okay, I have some base of 6. So as long as I find this altitude, great, I can find the area. Or if I have a base of 4, as long as I find this altitude that lines up at a right angle there, I could find the area. And I've been pacing around and I haven't been able to figure out how to find those altitudes. So then I was thinking of other strategies. I was like, got it. Okay, we got right triangles, right? So if I have a leg and a hypotenuse, I can find the other leg. If I have a leg and another leg, I can find this hypotenuse. And I'm like, does this new line on the picture help me at all? I don't know. I finally have an idea that I'd like to try out. I'm not sure. I'm not sure if it's going to work out, but I wanted to try it with you. So here's my idea. If I find this angle, then I can use this angle to find this height. And once I have that height, I can find the area of the triangle. And my current claim is that this angle that I really, really want is the same as the one up here in the corner. And my explanation why is, let's see, well, if you take this red angle down here and add it to this purple angle, we're going to get 90 degrees. That's this 90-degree square in the corner. Also, since I have a right triangle here, if we add up all the angle measurements, we're going to get 180. Though if you subtract out this 90, then these two angles have to add up to 90 degrees. So those two angles add up to 90, these two angles add up to 90, so therefore the two small red ones are the same. Okay, so that's cool, they're the same. So I could say that this angle up here, this, say, red angle, is going to be equal to something. I could use some inverse trig to figure that out. Let's redraw this right triangle where my red angle is going to be here in this corner. My right angle is in that corner. My hypotenuse is a 12 and the opposite side is a 4. So I know that I could write some kind of inverse trig expression that's equal to the measure of this angle. It's going to be, I think, sine inverse, because sine has to deal with opposite and hypotenuse. And then all I got to do is sine inverse of 4/12. Though I could reduce that fraction if I want to. That's the same thing as 1/3. And so I have figured out that this red angle in my diagram is equal to whatever this value is. And honestly, I'm not quite sure what sine inverse of 1/3 is, but I do know that it's some value, and it is the angle measurement of that red angle in the diagram in both spots. So let me take this idea and try to apply it to this bottom triangle. And in particular, I'm going to see if I can cut this blue triangle in half, like so, and get the height right here. So I don't really know what this height is just yet. And then the 6 is a little bit too long for me to actually make a triangle out of, but I do know that it's, there. I'll make a right angle here because my altitude, I can just kind of say, is completely perpendicular to the base of 6. And then this length is a 4, kind of from the problem statement. And then lastly, here is this red angle that I have there. Okay, sine inverse of 1/3. Sometimes when you're doing stuff with inverse trig, you could think about this as like drawing a triangle for you. And I'll show you what I mean. So sine, again, is opposite over hypotenuse. So I could draw a triangle whose opposite side is a 1 and whose hypotenuse is a 3. And then I'm going to get exactly that same red angle right here. However, my hypotenuse is a 4 in this blue triangle nonsense down here, not a 3, but I could scale up this triangle using some kind of scale factor. And I know that you can scale triangles up and down, and you're going to maintain the angle measurements. Even though you are changing the sides, the angles stay the same. So if I multiply this side by, well, 4/3, that's just going to be the perfect number to get me to this 4. I have to multiply this side by 4/3 in order to maintain all the angles being the same. So I have just created a right triangle whose hypotenuse is a 4 and whose opposite side is a 4/3 that has this red angle right in here. So from this, I can tell that my height, this h, has to be 4/3. And that's perfect because now I have a triangle and I know its base is 6. I know its altitude is 4/3. And I could just use the standard like triangle area formula to figure out the area of this triangle. The formula just says half base times height. You can kind of think of it as like if we had a rectangle and we had a base and a height and you just cut it in half, you're going to get the area of a triangle. And even though this one's a little bit weirder because it's an obtuse triangle, the formula still holds. So I'll do half. Base was 6. The height was 4/3. And then if I just do the arithmetic here, I should get the number 4 because that's today's date. I have a 6 times a 4 on the top, so 24. I have a 2 times a 3 on the bottom, so that's a 6. And then 24 divided by 6 is 4. So that is the area of the blue triangle right there in that diagram. So that's my solution. I hope you enjoyed. Thanks for coming along. I'll see you next time.